Khan Academy linear equation word problems. I've kind of snipped a few of the problems out of this section to kind of help you out and give you a hand. So let's jump right into it. So the first one says, a charity organization is having a fundraiser. P represents the profit. So over here to the side, I'm going to kind of try to get all this stuff down here. So P is our profit, how much money we make after we pay all our bills, in dollars, if N tickets are sold. So we have 70 being multiplied times N. So those are our tickets that we sold. Tickets sold. And a negative profit means the expenses exceeded the income. So if we end up with a negative number for P, we didn't cover our costs. So we have an equation here. And so let's see what they want to know. What are the expenses from the fundraiser? So the expenses are how much did the stuff cost? Well, it looks to me like, the 70 times N means that it looks like it's going to be $70 per ticket sold. But if we made a little bit of a chart, you don't really have to do this, but if we made a little bit of a chart here, and we kind of said, well, what if we sold one ticket? Now, if we sold one ticket, that would be 70 times 1 minus 1,500. Well, that's going to give me an answer of negative 1430. And let's take it a step further. Let's say that we sold 0 tickets. Nobody showed up to buy. Well, then we're going to be 1,500 in the hole. So I think that 1,500 represents our expenses to the fundraiser. All right? And the $70 per ticket is starting to get me in the positive direction. And then the big question would be, how many tickets do we need to sell to where we break even? And then we can actually start getting into positive territory and making a profit. So that could be a spin-off of this question. All right, moving right down, we have another sumo wrestler here. It says a young sumo wrestler decided to go on a special diet to gain some weight. W is the weight. So we have the weight here. And it's a function of time in months. So we have weight equals 80 plus 5.4 T. And it said that T represents months. So this kind of reminds me of back when we were doing linear models, interpreting and constructing linear models. So remember, in terms of slope-intercept, this is our y-intercept, the 80, the number by itself. And this 5.4 represents our slope, or our rate of change. So our weight is changing every month, and the y-intercept is our starting point. So it looks like we started at 80. So if I kind of make a little table, sometimes that helps to let us know what's going on. At 0 months, well, if I plug 0 in for T, I'm going to get 80. So that must be what my weight started at. Well, then 1 month later, if I plug 1 in there, I'm going to have 80 plus 5.4 times 1, and that's going to give me 85.4. If I plug 2 in there, I'm going to have 80 plus 5.4 times 2, which is 80 plus 10.8, which will be 90.8. And you'll notice all our change in W is, it's just our slope. It's going up by 5.4. And then, our change in T was 1, so that's why it's 5.4 divided by 1, so the slope is 5.4. Our intercept, or our starting amount, is 80. So what does this want to say? How much weight does the wrestler gain every 2 months? Well, every 2 months, all right, if we're gaining 5.4 each month, okay, for 2 months, we're just going to double that. So in 2 months, we went from here to there. So it looks like we had a gain of 10.8 kilograms. I think the chart or the table is very helpful in a lot of these word problems. All right, a couple more to look at here. when Quinn got home, he turned the air conditioner on. So we have a little chart, and I'm just going to start right off with the table. T and big T. And I like to start at 0. And big T represents the temperature, and little t represents the minutes, or the time. So we have an equation, big T equals 42, that's our starting point, minus 0.7 T. So we have our y-intercept, aka where we start at, and then we have our slope, aka what it's changing by every single time. So when you plug 0 in for little t, we just get 42. So that means right when he got home, the temperature is 42 degrees. So, but they didn't ask that. They say, how fast did the temperature drop? Well, every single minute, you know, if he cranks the thing on, he turns it on, and all of a sudden 1 minute later, well, we've dropped 0.7. So now we're going to be at 41.3. After 2 minutes, we would drop another 0.7. 3 minutes, we would drop another 0.7. So it looks like we're dropping 0.7 degrees per minute. They're basically on these questions just trying to see if you know what these two numbers represent or what they mean. I would use a table to help you out. Last one. The big ship drops its anchor. E represents the elevation relative to the water surface. And T is time. So let's go ahead and let's make our little chart over here. So we have elevation, we have time. Our time is in seconds, and our elevation is in meters. And it looks like if I put 0 in for T, my y-intercept is 75. So we're starting 75 meters above the water surface. So this must be a huge ship, big ship. All right. Well, if I do the equation, E equals negative 2.4 T plus 75, well, if I put 1 in for T, that's going to be a negative 2.4 plus 75. So that's what, 72.6? So our anchor is getting closer to the water. You know, if I skip down here at like, 10 seconds, 10 times 2.4, well, that's 24. So I'd have a negative 24 plus 75. Well, that'll be 51. So it's getting closer to the water. So how far does the anchor drop? Every 5 seconds. Well, let's go down here and let's put 5 seconds in. If I do a negative 2.4 times 5, well, that's going to be a negative 12 plus 75. So that's going to put me at 63. So basically, in 5 seconds, we dropped 12 feet in 5 seconds. So we dropped, or not feet, we dropped 12 meters in 5 seconds. So again, big tip here is use the table. I think it'll help you out.